Good morning. I'm discussing about the uh, some topics we have to know before the study of the reaction mechanism, or we should understand some basic terms to understand the reaction mechanism. First of all, elementary classification of organic reactions. Organic reactions may be broadly classified under four headings: substitution reaction, methyl chloride reacts with sodium hydroxide, gives methanol and sodium chloride. Addition reaction, the another substrate is substituted on the substrate. For example, in this ethene have the added the bromine. It is the addition reaction of the bromine. In the mechanism, here is the double bond, the maximum electron density is higher. But in case of the bromine have the electronegativity, higher electronegativity. So one bromine atom have the partially negatively charged, and another one is the partially positively charged. That's why the electrons flow from this alkene double bond electrons to this partially positively charged bromine. And the positive charge is induced in this carbon. And so again, also this bromide ion have a negatively charged, and it is attacked this positive charge and neutralized by this positive charge. Elimination reaction. Elimination means the removal. In this reaction, the halides, the halogen is removed by the alcoholic potassium hydroxide. Rearrangement reaction. The substrates, this arrangement of atoms in another ones. For example, this W is bonded to this A atom, and it may also bonded with the B atom. This is the catanotropic rearrangement, electrophilic or catanotropic rearrangement. Similarly, nucleophilic or inotropic rearrangement, also this as before I've discussed, this W is bonded with the A, and this will be again bonded with the B. This is the nucleophilic and inotropic rearrangement. Also may be free radical rearrangement. This free radical rearrangement also rearrange in the free radical is in this B atom. It may also be in the A atom. Similarly, this cation and anion of the atom may exchange. This is the electrophilic or catanotropic rearrangement is the rearrangement of this anion, and rearrangement is this cation is the nucleophilic or inotropic rearrangement, and this is the arrangement of the free radical. It's free radical arrangement. Breaking and making bonds in the reaction mechanism, it may breaking down or making bonds. For example, these are either breaking down the bonds. In this example, B atom has the higher electronegativity than A. That's why B is the negative charge and A is the positive charge. Similarly, if A have the higher electronegativity than B, and A is the negative charge and B is the positive charge. This is the heterolytic fission. Heterolytic means if W and Y is the higher electronegativity, these covalent bonded electrons may attracted towards the higher electronegativity Y. That's why this the heterolytic Y negative charge and W is positive charge. And also W is the more electronegative, and also may become W negatively charged. Reaction intermediates, carbon radical have This is the homolytic fission, as I have discussed already about uh, heterolytic and similar to homolytic. In this example, the A and B have this similar uh, electronegativity. In this case, two electrons dissociated as the free radical. This is the also called carbon radical. This is the free radical, and free radical may propagate. This is the propagation, and also it's become bonds is the termination. This is the example of propagation. And carbonium and carbocations, this is the mid tertiary alcohol is with 3-degree carbocation more stable. And also the chlorine have the high electronegativity, that's why it becomes the carbocation. Carb enhance is the negative charge on the carbon is called carb enhance. C and in hydrogen and this hydroxide, uh, these are the negative charge on the oxygen, and the hydrogen and carbon have this covalently bonded. In this case, the carbon have the higher electronegativity than hydrogen. So this hydrogen is the partially positively charged, and carbon is the partially negatively charged. That's why this hydrogen is moves towards the hydroxide and produces carb enhanced. This is the primary carbonyls, this is the secondary, and this is the tertiary carbonyls. Carbines, the carbon with the lone pair 2 electrons is called carbines. Intermediate, allyde intermediate formation. Reaction with carbines, addition reaction with ethene, allyde formation, and insertion reaction. Nitrines. The nitrines is the lone pair electrons to the nitrogen atom is called the nitrines. Thermolysis or photolysis of azides. Reaction of nitrines, addition reaction, allyde formation, and also insertion reaction, and nitrines similar to carbines. Benzines. The benzene with the 2 electrons is the benzene. This is the most common representation of the benzene. It's also called deuterion. It's a living group and produces benzene. Pi complex is the double bond of the benzene, like aromatic compounds shares with the electrophile. It's called pi complex. C. This metal and double bond is also pi complex. Sigma complex, if the sigma electrons forms the complex with a cation, is called sigma complex. Types of organic reagent, electrophiles that reagents with electron lovers or electron acceptors are electrophiles. Similarly, the electron donors are the nucleophiles. Methods determining the reaction mechanism, isotope labeling. See, this oxygen have the deuterium water, so atomic weight 18 of oxygen, and when this oxygen have this alcohol, so the confirms that mechanism in addition elimination weights added 18 oxygen is eliminated. Stereochemical kinetic studies, we study stereochemistry, this the transition state and this methanol. These are the basic terms necessary to understand the reaction mechanism. Okay, it's all about in the study of reaction mechanism, we have to know the following subjects. Thanks for watching, and all your requests subscribe, share, and comment. Thank you for your patience. Let us know. Bye bye. See you again.